For almost 800 years, one question haunted historians. How could a relatively small tribe from Mongolia spread across nearly all of Eurasia and then seemingly vanish? Empires leave ruins, dynasties leave monuments, but the Mongols left something else, something hidden. Because when geneticists began analyzing DNA across Asia and Eastern Europe, they found a pattern that should not exist. The same male bloodline appearing again and again across thousands of miles, from the Mongolian steppe to the edges of Europe. At first, researchers thought it was a mistake. It wasn't. What they uncovered may be the largest surviving genetic legacy ever linked to a single empire in human history. And it suggests the Mongols never truly disappeared at all. They multiplied. For centuries, the Mongol Empire has been remembered through destruction, burned cities, collapsed kingdoms, walls covered with stories of slaughter. To much of the world, the Mongols arrived like a natural disaster, sudden, violent, unstoppable. And then, just as suddenly, they seemed to fade. The empire fractured, its rulers disappeared into other cultures, its territories broke apart. Over time, the Mongols became something distant, a civilization frozen in paintings, chronicles, and legends. But genetics is changing that story completely, because genetics preserves something history often loses: movement. When scientists began tracing genetic patterns connected to the Mongol era, they discovered evidence of expansion on a scale almost impossible to comprehend. Not just political expansion, biological expansion. The roots of that story begin deep in the eastern Eurasian steppe. Long before Genghis Khan, Mongolia was home to mobile horse-riding societies adapted to one of the harshest environments on Earth. Life here demanded movement. Entire communities followed herds across open plains stretching thousands of kilometers. Power belonged to mobility, to horses, to clans capable of surviving constant instability. Empires on the steppe rose and collapsed repeatedly. The Xiongnu, the Turks, the Roran, the Uyghurs, each dominated for a time before breaking apart. But in the early 13th century, something unprecedented happened. A leader emerged who did more than conquer rival tribes. He reorganized the structure of the steppe itself. Temujin, later known as Genghis Khan, united fractured clans through military discipline, loyalty networks, and ruthless political restructuring. And once the steppe unified, the expansion became explosive.
Within decades, Mongol armies crossed enormous distances at terrifying speed. Northern China fell, Central Asian kingdoms collapsed, Persian cities burned, Russian principalities submitted. Horsemen from Mongolia reached the Middle East and Eastern Europe within a single lifetime. To the civilizations facing them, the Mongols appeared unstoppable. But historians eventually realized something strange. Conquest alone could not explain the long-term impact of the empire. Because centuries after the Mongol state fragmented, a genetic shadow remained. The discovery began with Y-chromosomes. Unlike most DNA, Y-chromosomes pass almost unchanged from father to son. That makes them useful for tracing paternal lineages across generations. In the early 2000s, researchers studying Y-chromosome variation across Asia noticed an anomaly. One particular lineage appeared at unusually high frequency across a massive geographic region once connected to the Mongol Empire. From Mongolia to Central Asia, into parts of Siberia, across territories linked to old Mongol expansions. The pattern was too large to ignore. Millions of men carried closely related versions of the same paternal line, and the estimated expansion date aligned closely with the rise of the Mongol Empire itself. The implication was staggering. One elite male lineage had spread with extraordinary speed during the Mongol era. Researchers estimated that roughly 1 in every 200 men alive today may descend from this single line. That means tens of millions of living descendants. While scientists cannot directly prove the lineage belongs specifically to Genghis Khan himself, the geographic spread, historical timing, and demographic explosion all point toward the same conclusion. The Mongol imperial elite expanded not only politically, but biologically. This changes the scale of the Mongol story completely. Most empires conquer territory, few leave detectable genetic footprints centuries later. The Mongols did. But the real surprise is how that legacy spread. Not only through conquest, through integration. As Mongol rule stabilized across Eurasia, the empire transformed into one of the largest interconnected systems the world had ever seen. Trade routes reopened, caravans crossed continents under Mongol protection. Merchants traveled between China, Persia, and the Mediterranean. Diplomats, artisans, engineers, and entire communities moved through imperial networks that suddenly connected distant worlds together. This period became known as the Pax Mongolica, and genetically it mattered enormously. Because populations that had once remained relatively separated suddenly began mixing at unprecedented scale. East Asian ancestry spread farther west. West Eurasian ancestry moved deeper into Central Asia. Communities once divided by geography became connected through imperial infrastructure. The Mongol Empire was not simply an army moving across maps. It was a machine accelerating human movement itself. Ancient DNA recovered from Mongol-era burials is now helping scientists reconstruct this transformation directly. The evidence reveals something fascinating. The empire was never biologically uniform. Individuals buried in Mongol period cemeteries often carried mixed ancestry profiles combining East Eurasian, Siberian, Central Asian, and West Eurasian components. This explains why historical accounts from different regions often described Mongol armies differently. Some saw East Asian faces, others saw Turkic, Central Asian, or mixed. Now the reason is becoming clear.
The empire continuously absorbed populations as it expanded. Tribes joined voluntarily, others were conquered and integrated. Military units reorganized entire communities into new political structures. Being Mongol was often less about strict ethnicity and more about loyalty to the imperial system. Over time, that system became genetically diverse. But despite this diversity, one thing remained remarkably stable during the empire's rise: an Eastern Steppe elite corps. Genomic studies from Mongolia show strong continuity between early Mongol-era populations and older Eastern steppe groups connected to ancient populations of Inner Asia. The Mongols did not emerge suddenly from nowhere. They were part of a much deeper steppe continuum stretching back centuries before Genghis Khan. What changed under the Mongols was scale. No previous steppe empire had connected so much territory so quickly. No previous expansion appears to have spread elite paternal lineages so successfully across Eurasia. Even after the empire fragmented politically during the 14th century, the biological effects continued. Regional khanates separated, dynasties weakened, local rulers assimilated into surrounding cultures. But DNA does not collapse with governments. It keeps moving silently through generations. Today, traces of Mongol-era expansions remain visible across enormous parts of Eurasia, not only in Mongolia, but in Kazakhstan, Uzbekistan, southern Siberia, northern China, parts of Russia, throughout Central Asia. The empire disappeared from maps, but not from populations. Perhaps the strangest part is this: most descendants have no idea the connection exists. Modern national identities create the illusion of stable ancestry: Kazakh, Uzbek, Mongolian, Chinese, Russian. But steppe history rarely respected modern borders. For centuries, populations moved continuously across Eurasia. They mixed, merged, fragmented, reassembled. The Mongol Empire accelerated all of it, which means its true legacy may not survive in monuments or royal tombs. It survives inside people themselves, invisible, undetected, carried silently across generations for nearly 800 years. This is why genetics is transforming history. Written records preserve what rulers wanted remembered. DNA preserves movement, migration, expansion, integration, the things chroniclers often failed to understand while they were happening. For generations, the Mongols were remembered primarily through fear, but genetics reveals something larger. Not just destruction, connection. One of the greatest population movements in Eurasian history, a biological legacy so massive that scientists can still detect its outlines centuries later. So did the Mongols disappear? Politically, yes, empires always collapse. But biologically, the evidence suggests they never truly left at all. Their descendants are still here, spread across continents, a living echo of horsemen who once rode out from the Mongolian steppe and reshaped the human landscape of Eurasia forever. If DNA can still detect the shadow of the Mongol Empire after nearly 800 years, then history may be carrying far more ghosts than we ever imagined. Subscribe to GenealogyX, because the past isn't gone, it's still alive inside us.